All right, today we're going to throw some plane geometry at you. When I say plane geometry, I'm talking about lines and angles, things that can be drawn on a sheet of paper, a plane. So let's start off by naming these figures, and in the process, we'll kind of define what they are as well. The first figure we have is actually an infinite number of points extending forever in both directions, as indicated by those arrowheads there. So this is called a line. And to name a line, you just simply name any 2 points on the line and you put that symbol right above it. Okay? And it does not matter which order you put these points in. We could call this line QP as well. So line PQ, line QP, they're the same thing. If there's other points in the middle, it doesn't matter which ones you use. As long as you use any 2 points that fall on the line, put that symbol above. It's tough to name a line incorrectly. Now this object down here, which starts at a point and extends forever in one direction, that's called a ray, and that's a little bit different. Here's how we name a ray. We have to start it with the point where it begins, and then any other point on the line. So this one, this P is very important because that's the starting point. Okay, and then any point over here that's named, you could use. You can't name this ray QP because that would be a ray that starts at Q and extends forever through P. So that's the only way you can name this one. And then the last one, it's got 2 endpoints. It does not extend forever in either direction. We call that a line segment. In the line segment, you have to name the 2 endpoints and you put that line segment symbol above it. Order doesn't matter, but it does matter that you use the 2 endpoints. If there's points A and B here in the middle, they should not be a part of the name. Okay, so that's how you name lines, rays, and line segments. Let's describe each pair of lines. Okay, the first set of lines is called a set of parallel lines, and the second set are called perpendicular lines. Okay, let's go back to parallel, and perhaps you want to write down a definition as well with this. Parallel lines are lines that never intersect. Intersect means cross. They never intersect, they never cross, and they're on the same plane. These are on the same plane. They're both on the same screen that you're looking at. This whole screen would be called a plane, and we haven't indicated that one's on this plane and one's on another plane. So they're on the same plane and they never cross. Those are parallel lines. If they're not on the same plane, say one's going left to right and one's coming right at us, but they never cross, we don't call those parallel lines. We actually call those skew. Skew, S-K-E-W. So lines that are on different planes but never cross are called skew. Lines that are on the same plane but never cross are called parallel. And perpendicular is a lot easier. It's any 2 lines that meet at a 90-degree angle. 90 degrees, also called a right angle. We call those perpendicular lines. And I just talked about a right angle. Now we're going to describe each angle as acute, obtuse, right, or straight. So let's look at CMD. Angle CMD, I've indicated it with that red marking. CMD, M is the middle because it's our vertex. It's less than 90 degrees, so we call it acute. Maybe you want to scribble that definition down. Less than 90 degrees is acute. CMA, I'll indicate that here in green. And we call that an obtuse angle because it is greater than 90 degrees. So obtuse angles are angles that are greater than 90 degrees. How about angle AMB? AMB is that 90-degree angle right there, and I'm indicating that with the blue mark. 90-degree angles are called right angles, so they equal 90 degrees. And AMD, all the way across, some wouldn't even call it an angle, but it is. We'll call it a straight angle. Straight angle. So if it makes a line, it's called a straight angle. If the measure of angle DMC is 45 degrees, then what is the measure of angle CMA? Okay, so we're referring to the previous example here. So they said DMC, it's that acute red angle that we named. First we called it angle CMD. Now we're calling it DMC. That's the same thing. Doesn't matter as long as you have the M in the middle. And they want to know, or that is 45-degree angle right there. So what is angle CMA? CMA is this green obtuse angle. Okay. Well, here's what I do know is that when we put those two angles together, they make up a straight angle. So DMC together with CMA makes a straight angle. And if you have a straight angle is always 180 degrees. So these two together, combined with each other, make up a 180-degree angle. And if we know that DMC is 45 degrees, we should be able to figure out what angle CMA is by solving this very simple equation. Angle CMA is 135 degrees because 45 degrees plus 135 degrees is 180 degrees. Okay, so if I was going to explain how I find my answer, and you should write this down when you're asked to do so, you would say something about how DMC together with CMA makes a straight angle. Straight angles are 180 degrees. So a 45-degree angle with a 135-degree angle would make 180 degrees. So CMA must be 135 degrees. All right, that's it. That's all I have for you today over our first lesson for plane geometry, dealing with lines and angles. And we'll work on this tomorrow in class. I'll see you then.